Alright guys, welcome back to another one. So here we go. Let's start with number 10. So figure 1 shows a semicircle with center O and radius 3. Okay, so if you got a center O and you know the radius, this means every straight line coming off it must have the same radius of 3. So this will be 3 and then this line will also be 3. Okay, next. So XY is the diameter of the semicircle. So that just proves it. The point Z is on the circumference such that angle XOZ is 1.3 radians. Yep, we see that. The shaded region enclosed by the chord, arc, and diameter is a template for a badge. So just quick recap. This line is a chord, so it does not pass through the center. Part of the semicircle, i.e. this part, is an arc, and the diameter is just the line cutting through from X to Y. Okay, so it's twice the radius. So let's move on to the actual questions. Now find, given each answer the 3 similar figures, the length of the chord XZ. Alright, let's work out the length of this line. So easy way to do this, let's just pull out this shape for a second, yeah? So anything relevant to it. So from here we can see that we have a nice simple triangle with length 3, angle 1.3 radians, and we're trying to determine this length here. So let's call it x, small x. Now look at this carefully. So basically for these kind of questions we need to determine what kind of triangle formula we're using. Well, it's either going to be the sine or cosine rule. Now to know which one to use, you should always use the cosine rule if you're dealing with 3 lengths and an angle. Otherwise use the sine rule. So in this case we've got 3 lengths and an angle. Let's use the cosine rule. Now the cosine rule formula is actually like this. We have an a squared which must be equal to a b squared plus c squared minus 2bc cos A. Now notice how you only got a single angle here, which is capital A. So what we do, because we've got 1.3 radians, this will have to be automatically labeled as A. That means the length opposite angle is small a. That means B and C would be the 3's. So let's go ahead and update this formula. So replacing little a with x, we've got x squared equals 3 squared plus 3 squared minus 2 times 3 cos 1.3. Now notice how all of this nicely equals x squared. So all we do now is literally smash this in a calculator. Now before you do that, make sure your calculator is set in radian mode, not degree mode, yeah? Otherwise your answer will look kind of messed up. Once you get the answer of this, to find x, we just square root the result. And then when you square root the result, you should have an answer which is approximately 3.63 centimeters. Because remember, they want answers in 3 single figures. Okay? Alright, perfect, that checks out. So now let's look at part B. So here they want to find the perimeter of the template XZYX. So in other words, we start from X up to Z, all the way down to Y, and then back to Z. Okay? So what do we know? So looking at this across, well, we just determined the length of XZ. It was what? 3.63. We have 3 here, we have 3 ready. So technically, we just need to work out what this arc length is. So let's go ahead and pull out this shape for a second, yeah? So, oh yeah, one thing to notice. Notice how we don't have an angle here. Now to work out an angle, at least on a straight line, we know generally from degrees that all angles on a straight line must add up to 180 degrees. So when it comes to radians, all angles on a straight line must add up to pi radians. Okay, so remember pi equals 180 degrees. So if this is 1.3, then this value here will be pi minus 1.3. Okay, so we can put that in a calculator. You could simplify that. But just for demonstration, I'll leave it like that. So, okay. So here's our value of angle. It's going to be pi minus 1.3. Therefore, to work out the length of this arc, well, the arc length is so easy. It's literally the radius times your angle, theta. So r theta. So since we know the angle is pi minus 1.3, we know the radius is 3. So it's just going to be 3 times pi minus 1.3. And when you do that, so I'm just going to write down here. So the length of the arc is going to be radius times the length, the angle, pi minus 1.3. So therefore, so whatever this gives you in a calculator, just put that in and add it to 3.63 and 3 and 3, and you should get a total perimeter of roughly 15.2 centimeters. Okay. Okay, part C. So now we need to work out the area of the template. Well, as you can see, the template here is made up of a triangle and a sector. So naturally, all you need to do is work out the area of this triangle first and then add it to the area of this sector here and done. You got the answer. So what is the area of a triangle formula and area of a sector? Well, the general formula for a triangle is always half AB sine C, where C is the angle between A and B. So looking back here, so let me just put a little triangle here. So look at this triangle. Since we know that the angle is 1.3, the lengths between angle is going to be 3 and also 3. So that's it. So this is going to equal half times 3 sine of the angle, which is 1.3 radians. And now for the area of a sector, it's always going to be half r squared theta, okay, where theta is the angle and r is the radius. So looking at our sector equation here, so our sector is this bit. Well, we can see that the angle we found before was pi minus 1.3, and the radius is, well, 3. So it's going to be half times 3 squared times pi minus 1.3. So in your case, if you already worked out this angle, well, just replace that instead. And then finally, to work out the total area, the area of the, the template, just add them both up. And when you add both of these up in a calculator, you should get a final answer of 12.6 centimeter squared. Alright guys, number 11. So the curve C has equation y equals fx for positive values x, where the first derivative, so this notation means when fx is being differentiated, equals this following equation. It is given that the point P at x when x is 4 and y is 14 lies on this curve C. Right, so we're given some few critical informations, yeah? By the way, when you have an equation like this, the first derivative, this is actually known as the gradient equation. So the y equals fx is the y equation. This is known as the gradient equation. Okay, let's look at part A. So find fx, right, in each term in simplified form. Alright, so it looks to me that you want to go from this equation and just integrate back into the regular fx. So let's try this out. But okay, before we integrate, we need to firstly rewrite this into its correct indice form, because you can't integrate something like that. It's a bit complicated. So how do we do it? Well, let's try and tidy up this fraction, yeah, and simplify it. So what do we have? So you can say that this derivative equation is equal to 5x squared over 2 root x plus 4 over 2 root x. So remember, distribute 2 root x to both, minus 5. So looking at both of these head on, 5 over 2 is just literally 2.5, or you can leave it as a fraction. X squared over root x. Well, we need to know that root x is the same as x to the power of a half. Okay? So therefore, when you got x squared divided by x power half, when you're dividing terms, you subtract the powers. So 2 take away half, it's going to be 3 over 2 or 1.5. So because we're using a calculator, we can use decimal. It's all good. Now plus, you got 4 divided by 2 is just 2. And now this is, again, x power half, but because it's 1 over and you bring it to the baseline, it'll be x to the negative half, okay, or negative 0.5. And then therefore, and you also got minus 5. So here we go. So this is so far the equation of f prime x equals that. Now let's go ahead and finally integrate to find fx, yeah? So we can say therefore for a, fx is the solution after you integrate this term. So integrating this, we're going to have 2.5x. So integrating, you simply add 1 to the power. So it'll be 1.5 add 1, which is 2.5, and then divided by itself over 2.5 plus 2x, and add 1 to minus half, which is going to give you plus half, so 0.5 over 0.5. And lastly, if you got no term, you just add an x. And finally, one thing we must never forget is the constant of integration plus c. Because if you're integrating 0, you'll be left with a constant c. So that's what we got so far. Now, oh yeah, find fx writing each term in simplified form. So let's go ahead and simplify what we got, yeah? So 2.5 over 2.5 cancels out. You're left with x to the power of 2.5 plus 2 over 0.5 is 4. If you're not sure sometimes, just put in the calculator, 2 divided by 0.5. And then 0 power 0.5 minus 5x plus c. Alright, so far so good. Now, just a quick note here, this c is not the same as that letter c, yeah? Even though it looks the same, they're not meant to mean the same thing. This is the constant integration. That's just what they label the curve. So to find this value c, they give us a little hint. They say it is given that the point P lies on C. So it's trying to imply that when x is 4 and y is 14, in other words, when fx is 14 and x is 4, you can substitute them in and rewrite to find the value of c. So let's try this out here. So we can say, all right, replacing fx with 14, replacing x values with 4, because that's what it is. We can now literally rearrange the solve for c, yeah? So let's have a go, guys. All right. So what I would do is literally, firstly, just literally put this all in the calculator. Whatever that gives you, in your calculator, you're going to write 14 minus that answer, and it'll give you that c value, okay? And then therefore, when you do this, your c value should ultimately become minus 6. And you're done. And then, of course, rewrite the equation in full, because that's what it wants. We can say, therefore, the function of x is going to be x to the power of 2.5 plus 4x to the power of 0.5 minus 5x minus 6. And we're done. And you don't have to put that star. That star means done. All right, so since we've done the hard bit, let's try part B now. Okay. So B is saying, find the equation of the tangent to C, so the tangent to the curve. A tangent is a straight line, by the way, at the point P, which is at 414. Giving your answer in the general y equals mx plus c form, where m and c are constants. Okay, let's have a look at that then, yeah? So one thing to note, every time you find a tangent, we need to firstly find a gradient. So tangent is just a straight line, and just imagine this is the curve C or something. It looks a bit like that, or it could be something different. This is the point P, because that's what they have in common. So every time we have a straight line, it always takes the form of y equals mx plus c, where m is the gradient and c is the y-intercept. C is easy to calculate, and it's not the same c as the previous question. Now to find m, literally we have the gradient equation right here. All we have to do is literally plug in the value of the coordinate we're interested in. So we know that at point P, x is 4, right? So at P, x equals 4. So we're going to plug in 4 into this gradient expression. So we're going to say, right, at point 4, replace all the x values of 4. And when you do that, which I've already done it by the way, you're going to get a total value of 16. So this means that the gradient at x equals 4 is 16. So that's one thing done. So we can say now that y equals mx plus c becomes y equals 16x plus c. Now, how do we get c? Well, again, we know that we're using point P as a reference. And if you recall, point P was what again? Was 414. So now just plug in your coordinates. So replacing x and y 4 and 14, you're going to get over here, which is 14 equals 16 times 4 plus c. And then just rearrange this in the calculator, work this out, and then in the calculator, 14 minus your answer, you're going to get a c value of minus 50. And we're done. It's literally as simple as that. So we can say, therefore, the general equation is going to be y equals, so just replace m and c, y equals 16x minus 50. And we're done.